Welcome everyone to this first session this afternoon, Retrofit, getting it right in time. So Retrofit, where to start? The built environment contributes to 40% of the UK's total carbon footprint. Approximately 47% of that is coming from our existing built assets. Newly constructed buildings are more energy efficient. However, 80% of the built environment will exist today in 2040 will have already been built, so the major priority here is decarbonising our existing building stock. So do we see this as a challenge or do we see this as an opportunity? Sarah Lewis from the Passivhaus Trust recently said that to achieve the UK 2050 targets, we will need to be retrofitting a building every 35 seconds. And we also need 2 million people in the retrofit industry, working in the retrofit industry, and currently we have 135,000. Okay, so we have a big opportunity here with 2 key major focuses that I see: upskilling, but also finding the correct technical solutions for retrofit. Today we have 3 experts here to talk about the opportunity at scale, some solutions that are already being developed, all slightly from different lenses, but with one clear mission, and that is to achieve a net zero built environment. We have Dr. Peter Rickaby, a Technical Director of the Retrofit Academy, Anne-Marie Fallon, Associate Director of Architype, and Matt Stephen, the Director of Ecosystems Technical. Before we get into the presentations, we have a poll, which I can see some of you have already started, hopefully, to put into order. And it's in order or in rank of the next steps. What do we see as the next steps? The retrofit challenge or the retrofit mission. Upskilling and reskilling the workforce. Main focus on archetype solutions. Heating systems are to focus on innovative building material solutions. And yep, like the ranking that's there. We will hear from each speaker and then we'll have an opportunity for discussion and questions. So firstly, I would like to welcome Dr. Peter Rickaby, and he'll be joining us via Zoom. Peter is a qualified architect from Cambridge University. He holds a doctorate in energy studies, and currently Peter is the technical director at the Retrofit Academy, and he helps run the Centre of Moisture in Buildings at University College London. He also is the chair of the British Standards Retrofit Task Group. And in addition to that, Peter is also the technical author of the UK's 2 new retrofit standards, PAS 2035 for domestic retrofit and PAS 2038 for non-domestic. So welcome, Peter.
Thank you, Caitriona. Just let me share my screen. Find that one. You should now be able to see it.
Yep, great.
Okay, so I want to set the scene really at a fairly high level. So good afternoon, everyone. What I want to do really is work through just 6 points over the next few minutes, some of which follow up some things that have already been said this afternoon. So first off, it should have changed, I hope.
Yes.
We have in the UK 27 million dwellings and about 2.2 million non-domestic premises. Non-domestic buildings are a bit more complicated because premises don't really equate to buildings. They overlap in various ways. But as already been said, the replacement is about half per year. So if you do the math, you find that about 80% or more of the existing building stock will still be around in 2040, 2045, 2050. And we've heard different estimates today, but somewhere between 30% and 40% of greenhouse gas emissions come from our buildings one way or another. So again, doing the math, it becomes fairly clear that if we're going to hit net zero carbon, which is obviously our ambition and our political commitment, then we need to do retrofit, and we need to do it at a humongous scale. So that's the first point, that we have a big challenge ahead of us. Second point is that we do know a lot about how to go about it. We've had programs like Retrofit for the Future, which the pictures from the right come from, where large numbers of housing association houses were retrofitted deeply and studied very thoroughly over a period of years to understand what works and what doesn't. The Construction Leadership Council has published a national retrofit program, and I think that shows the way. I think the Energy Efficient Scotland program is a good first start, but the CLC program goes into a lot more detail about things we need to do. And let's just kind of get a grip of the scale of the challenge. If we make the maths easy by saying we need to do 25 million retrofits in the UK between 2020 and 2050, over 30 years, that works out at about 5 per minute. And my 5 per minute is based on working hours, not 24/7. So that's why it's slightly different from the figures we just heard. But it's certainly a large number. 5 per minute is pretty challenging, whichever way you look at it. It's more than we delivered during the 60s when we were redeveloping housing. Whichever way you look at the cost, whether you work bottom up on individual dwellings and you do detailed analysis of what needs to be done and what it costs, or whether you work top down from stock data, either local or national, you end up with an average cost, pretty much £25,000 per dwelling to do the retrofit that we need. And that's different from many figures that are quoted, and it's lower than a lot of people in organisations like Passivhaus and Energy might suggest, but it's higher than the government and the devolved nations governments would like us to have to spend. And it's an average. And I make the point that the actual range around that average, when you do the analysis, is from the cheapest at £12,000 a dwelling to the more expensive at least £50,000 a dwelling. So although 25,000 is the average, there is a big variation across the stock to do with the nature of the buildings and their historic significance and their construction and their age and so on. If we look at 25 million domestic retrofits, again, just keeping the maths simple, at an average of 25,000, that comes to £625 billion. And that's an eye-watering number. And it's not going to come from governments. I think it's fairly clear from what the UK government has said already that there will be some money, there will be loans and grants, but a lot of this money is going to come from householders, landlords, financial bodies, and so on, as well as loans and grants. Loans probably for the able to pay, and grants for the fuel poor or the less able to pay. And if you want to put 625 billion into context, my view is that it's a matter of priority. And if you look at the bank bailouts and the quantitative easing payments made by the Bank of England since the 2008 crash, it comes to £1,500 billion. So it really is a matter of what your priorities are, what you intend to spend your resources on. So that was the second point. My third point is that doing 27 million retrofits in a short period is going to need a huge collective effort. And this week we've seen politicians starting to focus on some of these issues, but actually we need owners, landlords, tenants, the industry, the retrofit industry, the building industry, the finance industry, and the regulators to be involved as well. This is a community effort. It will be a collective effort. We're not going to get there if we just compartmentalize it into a problem for the retrofit industry. And as has already been suggested, we also need a huge training program to scale up delivery and upskill the industry. And I think that falls into two categories. First of all, retrofit professionals, coordinators, advisors, assessors, designers, and evaluators. And it also involves the supply chain, suppliers of products, materials, and systems, contractors, installers, contract managers. And we need lots more than we've got of all of those, and we're competing with lots of other jobs for their services, and in particular we're competing with the new build sector. So there's going to be a real challenge around bringing people into the industry, getting them to the right level of skill, and then deploying them. Fourth point, it's still best to think in terms of the fabric first strategy. Fabric First is a strategy that says reduce the energy demand of the building first, before moving on to think about heating systems and renewables, or indeed decarbonisation. And the reason why Fabric First is still the best retrofit strategy is that all the decarbonisation options we've got require demand reduction. Not one of the options we've been looking at will deliver the amount of energy we need across the stock without us getting more efficient. So let's take, for example, the most popular option, which is to electrify heat and then supply that heat via heat pumps. If we were to electrify heat and use it directly, use direct acting electric heaters, we'd need 30 times as much wind power connected to the electricity grid as we currently have, or the equivalent in other zero carbon sources like nuclear and solar and so on. But 30 times as much wind power as we currently have, it's taken us 30 years to get there. We're not going to do it again in the time available, times 30 in the time available. If we use heat pumps with an average coefficient of power of 2.5, then that 30 factor reduces to a factor of 12. So we could say that we could go for heat pumps everywhere, provided we can put 12 times as much offshore wind out there as we currently have out in the Irish Sea and the North Sea and so on. It's not really very credible to multiply our offshore wind resource by 12 in the next 30 years. But if we do 60% demand reduction through deep retrofit to reduce the demand not only for heating but also for hot water and so on, then we can reduce that factor of 12 to 4. And actually a 4 times increase in offshore wind production is exactly what's in the UK government's recently published heat and building strategy. So they're thinking along these lines. But we're often asked the question, do we need more insulation, Fabric First, or do we need more offshore wind turbines? And I think my point here is that we need both. We have to have lots more offshore wind to provide us with zero carbon power, but we also need lots more insulation to reduce the demand to the point where we can satisfy it with a realistic investment in offshore wind. So we need both. Fifth point, retrofit's risky. I've spent probably the last 20 years of my life working on retrofit risks and risk management, trying to understand what goes well and how to stop it going wrong and how to manage the risks in a coherent way. And that's what led to the Comprehensive Domestic Retrofit Standard, PAS 2038, you see on the right there, and more recently to PAS 2035, which you see on the right there, and more recently to PAS 2038, which is the non-domestic standard. And along the way, we've learned a lot about what the risks in retrofit are. And it's not rocket science, but it is complicated. We've learned what they are, and we've learned a little bit about how to manage them. And one of the things I've learned is that most technical risks are either related to moisture, that would be the majority of them, things like thermal bridging, thermal bypass, air leakage, condensation due to poor air quality, and so on. Or they're related to overheating, which is probably the measure that's going to come back and bite us over the next couple of decades as we over-insulate our homes and then don't deal with the overheating problem. Or they're to do with what we call the performance gap, unintended consequences, things that we didn't expect to happen. I think the performance gap is not a very useful term because it doesn't say anything. I think it's actually what I would call an attention to detail deficit. It's about not paying attention to the right details. And I know that Anne-Marie is going to talk about Passivhaus next, and one of the questions I think the idea that the performance gap is an attention to detail deficit begs is, well, what details? And my view is that the Passivhaus standard precisely defines the details we do need to pay attention to. The other point about risks is that government, whichever government, finance bodies, and indeed owner-occupiers of buildings are not going to invest in retrofit unless we manage the risks and we can deliver consistently good outcomes without those unintended consequences. If we can't do that, nobody's going to put their money in, and government is not going to promulgate policies and provide subsidies. And that was the reason for us having the Each Home Counts review a few years ago, in order to try and understand what the risks were and manage them to the point where at least government's confidence would be restored and they would be willing to move towards policy as they are now. So now we've got quite a good domestic quality assurance framework in the UK, based on Trustmark and PAS 2035 and the BSI Retrofit Standards Framework. And between them, they bring to bear on all publicly funded retrofit projects just about every best practice standard that we've got in the country, which are all part of the framework. So we bring to bear the right way of doing it in every way. And PAS 2038 is starting to do the same thing with non-domestic retrofits. So we should be looking to adopt PAS 2035 and PAS 2038 and the retrofit standards framework and quality assurance procedures that they present us with across the board in the industry. Which leads me really to my last point. There isn't much time. And I've been listening recently to people, particularly in the social housing sector, talking about demonstrators and trials and test installations. The time for those things is gone. We've been doing those things for nearly 30 years, and more over the last 10 or 15. We know how to do good, safe retrofit. What we need to do now is get our heads down and deliver safe, robust retrofit at scale. And talk about demonstrators is way out of date. There's not enough time. What we do know is that when we get it wrong, such as we did in Preston at Fishwicks, in Hull, in North Wales and in South Wales, and in lots of other places on a smaller scale, then putting bad retrofit right takes about 5 times as long and costs about 5 times as much as doing it properly in the first place. So my kind of parting point really is that if we have to do 5 retrofits per minute, we need to work very hard to make sure we get them right, because we can't afford either the time or the money to get it wrong and go round again. Thank you.
Thank you so much, Peter. And we'll take questions from Peter at the end of the session. Really, Peter highlighted some key points there, and point 5 and 6, I think, being really important, you know, in terms of the risks, and we're out of time now. I'd just like to now introduce Anne-Marie. Anne-Marie Fallon is one of the UK's leading experts in passive house design. She shares her experience, she's shared experience with the UK and international Passive House Trust conferences. She is leading the Architype team to develop innovative process to create compatible workflows for passive house and building information modelling implementation. She has successfully delivered award-winning UK large passive house residential schemes such as Algarve Grove, and since focusing on the development within their Edinburgh office, she has overseen the delivery of several passive house schools and secondary schools within Scotland, and she also brings expertise in Retrofit, which is the passive house standard for retrofit. Welcome, Anne-Marie.
It's a really intimidating introduction there, Caitriona. Thanks for that. Hi, everybody. Great to be following someone as formidable as Peter and his really great, sharp, to-the-point presentation. So hopefully mine is too. And I'm a bit blind after spending 18 months working in my spare room, so I'm going to have to maybe even go down close to the screen. Oh, there is. Oh, there you go. Oh, that really helps, yeah. I can point at this now and tell everyone what to look at. Okay. So I suppose myself, I completed the first Irish Retrofit a decade ago in the middle of the Irish recession, and I completed Architype's first residential Retrofit. You probably don't see that really too much on our websites, and I think retrofit and Retrofit and looking at existing buildings has become part of architects' general workload across the board. And of course, we're always trying to push that to a particular standard energy methodology, which is adopting and having a look at passive house. Can I flick? Oh, I have to point it at something. Is the battery working on the... No. Okay. This is... Oh, there we go. Oh, okay. And maybe I go backwards to go forwards. Oh, there we go. Okay. Okay, so we've been around as Architype for about 35 years. I've been with Architype for the last 5, and we 2.5 years ago opened our new studio in Edinburgh. And we also have a sister consultancy operating alongside the practice called Perform, which deals specifically with kind of building aftercare, post-occupancy evaluation, and we also do quite a bit of hygrothermal moisture and transport modelling, thermal modelling, and that's, you know, as Peter's alluded to already, really critical that we're able to provide robust solutions at retrofit level. There's a wide range of typologies and scales and sectors that we've been working with, and again, Passivhaus isn't just around Passivhaus residential projects. We've looked at archives, offices, university buildings, primary schools, secondary schools, and business centres. And a lot of our work has come from lessons learned on our own project post-occupancy evaluation, as well as other buildings. And a lot of lessons were learned through the evolution of our educational design, and I'm going to focus on that as part of the retrofit presentation today. So some of you are probably well familiar with this, but the Scottish Government's kind of agenda and the energy agenda has been very ambitious. I suppose most critically for us, there was the new Scottish Futures Trust school metric, cost metric that was set in 2019 and had real emphasis on influencing quality, informing quality, looking at statutory regulation upgrades and associating the Cole report with better building. And Passivhaus has been adopted as that methodology by Edinburgh City Council for their new educational buildings as a quality assurance tool that that's informing their energy agenda, but also their build quality agenda. I think the area to focus on today is around the recognition of need to promote the refurbishment of buildings. Okay, so nothing's really in stone yet or kind of in policy yet, but I think it absolutely is coming. And what we're trying to avoid is this position of having stranded assets, exactly as Peter's just delved into it a bit more detail, where we're going to be in a position in a couple of decades' time where we can't go back to fix where those carbon issues are locked in at this point, and we want to be able to, we'd rather not retrofit now and wait to try and retrofit more deeply later to avoid that carbon lock-in scenario, and that's been reported on by the Climate Change Committee in a couple of papers over the last few years as well. So Edinburgh City Council came to us and said, right, we have 400 buildings, 2030 is 9 years away now, we just want to stop talking and we want to actually do, we want to apply how we're going to get to net zero. In operation, so it's important to say net zero carbon in operation is the standard and strategy that's been set for 2030. So I suppose, where do you start with an estate like this spread all over a heritage city with lots of complexity, lots of really special buildings that aren't going to be covered in tea-cosy insulation, and also lots of 1970s, 1960s office and educational buildings that are actually quite opportune and ripe for economical retrofit. So we tried to phase the study, which we're coming to the conclusion of now just after Christmas, where we, of course, have to assess the existing estate and look at those 400 buildings and categorise them and try and create, a library of building characteristics. Because as Peter's already alluded to, we need to have very specialist, specific solutions for retrofit. It's not just a one-size-fits-all. I referred to the tea-cosy. We can't just apply a kind of a blanket approach to retrofit. It is site and cost and job specific. We took and worked with Edinburgh City Council to choose 12 pilot buildings, 6 of which we've completed the feasibility analysis on so far, that represented a large body of their estate. Okay, so what they felt they would get the most value out of when we then go and project those findings on a much deeper level across the remaining 400 buildings. And that, we're working closely with a team from Curry and Brown and Harley Haddo looking at this. So there's genuine deep cost estimate plans sitting behind the energy analysis, and also very detailed MEP plans. So it's not just a REBA Stage 01 feasibility. This is what I would term as a deep dive assessment. And the schools and buildings are from a number of different eras. I think a critical part about this feasibility is that the methodology we developed in a very collaborative way alongside the capital programme team at Edinburgh. And we identified the issue that, well, actually, it's not just the capital programme team that will be making this decision. There's politicians, there's funding bodies, there's the Scottish Government. We need to be able to provide the stakeholders with a decision-making tool or a method of being able to come to reach a decision about what the priorities are. We know energy is an absolute priority, but there's other feed-in priorities to that we need to pay heed to. And also, we're working in a heritage city, so we need to be mindful of the building characteristics and allow them to really define how we develop this feasibility into 12 live projects next year. So this is very much informed by the 2038 PASS methodology that Peter's been talking about. And this idea that you need to start a project with an informed retrofit plan. So we've coined it the Enerfit Informed Retrofit Plan. Patrick from City in Edinburgh has coined that term because in not all situations or cases, perhaps, can you get to full Enerfit. And indeed, you know, looking at the previous slides from Peter, there's this 60% minimum reduction in energy demand that we must achieve, which we can then offset or complement with some renewable energy. So we may not be able to get to 90% improvement for every single building, but we can certainly try and set out a quality assured methodology to ensure that happens in a safe way for these buildings. So how did we further inform ourselves in part of this feasibility? We went in for a deep dive assessment. So we didn't just assume an air permeability target. We didn't just assume that, you know, we generally had no insulation everywhere. We undertook thermal imaging. We carried out some in situ U-value monitoring. We carried out air tightness testing and infrared thermal imaging, external and internal photographs earlier on this year on all the buildings, including a 3D cloud survey of buildings that may not have had that asset data in place already as well. And that's part of the asset management development that's happening in the local authorities across Scotland at the moment as part of the SFT's standard information plan modelling for future new builds and hopefully covering also existing buildings in the future. So the first building that I'm talking to you about today, because I'd probably be here all afternoon if I was going through them all, is Liberton Nursery, so a small, non-listed Victorian nursery within the borough of Edinburgh. And the air permeability, we're looking at 12 metres cubed per hour per metre squared. To put that into context, for a Passivhaus standard building, we'd be looking at less than 1 in terms of air permeability, not air changes. Very little insulation, a number of areas where there's very leaky, permeable roof spaces, suspended floor, single glazed sash windows. Everything that's quite special about the characteristic of this building is also the energy problem that's sitting within this building, within the estate at the moment. And this graph here, hopefully you can see, we also took an appraisal of where the heat loss was coming from the most. And we wanted to create a kind of a bespoke approach to try and manage, to retain some of the special characteristics, but also do the most meaningful retrofit that we could. And we've come up with a series of different graphs that have developed on a lot more since these graphs were developed, showing a series of interventions and how these interventions can be carried out in whether it's step by step or whether it's in total single project completion. In terms of its evolution is all part of that process as well. And where we started from was the baseline. So we have gas boilers, an existing energy demand that's very, very high and unsustainable, and as Peter's outlined, you know, is not acceptable as we're going forward to just accept that as the baseline, even if we try to offset with renewables. The next steps, kind of at step 2, are really about looking at, right, if we just introduce heat pumps and we don't do anything to the fabric, well, we still have the same energy demand, but we magically are emitting less carbon emissions because we've turned to a decarbonised fuel, or a fuel that allegedly will be decarbonised by 2030. If we just go on to option 2B, 3A, 3B, and we start incrementally bringing in more fabric improvement, we suddenly see some significant reductions in energy demand. And of course, we've pushed it just in this option 4 as a certified retrofit at Enerfit standard. So that's either via component or by energy demand. There's certain criteria that you need to meet. But of course, in reality, we need to be very, very careful with trying to look at that level of insulation in a building like this and be very mindful of the moisture risk that internal insulation brings with it. So there's a maximum U value, minimum U value that's specified by the Institute to not go below for internal insulation, which is 0.3 watts per metre squared Kelvin. So we know there's lots of products out there in the market that are really targeting lower values than that for internal insulation, but it's not really hygrothermally safe to roll out something like that at scale. So one of the points of interest for the council was, you know, we have this challenge. You know, we have one part of our group saying, well, look, we'll just roll out heat pumps, we'll look at heat networks, we don't need to do anything to the fabric, don't worry about that. And I suppose the point of this study as a discussion piece is to really challenge that notion. And, you know, more importantly, the big elephant in the room at the moment is the cost of just installing huge heat pumps and the cost of running those over a period of time would be really, really significant on the public purse. So even if, you know, we are concerned what budget financial support comes out of, it's still coming out of a budget somewhere, and that's, you know, the public purse is being held to account for that. This is just a bit of a benchmarking exercise. So again, on the left there, we see that the new schools high target, the A target for the new school buildings at the moment by Scottish Futures Trust is 67 kilowatt hours per metre square per year. And that actually, you know, we could get the energy use intensity of many of these buildings down to in and around that standard. And I can't even read these myself now, but I'll tell you what they're saying. So the top graph is showing what the kilograms of CO2 would be per year in terms of annual emissions. So you can see the difference straight away when we change from gas to heat pumps. We suddenly get down to that magic number. Now, the carbon factors we've been using for this are the BEIS carbon factors for 2032. The next projected emissions targets, not today's carbon emission factors, but where we would be by 2030, which is another, I think, important statement to make. The graph on the bottom then is just showing the embodied carbon. So, of course, we are adding a little bit of embodied carbon into these buildings because we are adding materials. But when we look at whole life carbon in a second, we'll show you that the benefit far outweighs it due to the operational energy reduction. And then that's that graph just on the top there. So on the left-hand side, that's the gas that you can see in bright blue if we kept with the business as usual approach, i.e. no retrofit. And the two options on the right, option 3 and 4, so, you know, as full, a deep retrofit as we possibly can. We see that operational energy in a whole life carbon scenario reduced down so much that the extra embodied energy put into that building in terms of materials to retrofit it is very minimal. Now, in terms of the material choices in our simulations, we looked at organic, hygroscopic insulation as much as we could, rather than sticking kind of closed cell insulation on the building for a quick fix. And lastly, the graph in the bottom then, the line in blue is the business as usual approach for whole life carbon over, I think it's 60 years. So, you know, as architects, typically we're tied into contracts for 60-year building lives. And the two options on the bottom show that huge reduction in whole life carbon over a cumulative time period with retrofit. The top two deep retrofits played out on this building. So let's say on this building we went with our option 3B, which was, you know, almost full certified EnerFit, but just not quite, just trying to be more representative of what we can achieve maybe on an average basis. So that's about a 66% reduction in energy demand. So we're down under that target that Peter has been talking about already. We have a 90% reduction in carbon emissions, which is quite significant, okay? So just by changing to electric, we're getting an assumption that we'll be lower, you know, a lot lower in emissions, but actually carrying out that extra fabric measure allows us to have energy demand reduction as well. And I think Peter's already said this, where we sometimes divorce energy demand and energy demand reduction with zero carbon. We just think, look, we're going to stick heat pumps and PV panels everywhere and we'll be grand. We're not thinking about that consumption reduction, and we really should. And interestingly, even though electricity is costing more at the moment than gas, we are looking at an almost 40% reduction in running costs off the existing bills in gas. And I think that's a real critical issue for fuel poverty, is that, you know, if we decarbonise and install heat pumps everywhere, and the electricity market is very volatile, it's not dropping. I know local authorities love looking at discount factors, saying that, you know, well, we apply 6% discount factor and 3% inflation for the next 30 years, electricity is free, you know, we'll be fine. That's not the case. We're looking at energy price rises in the very short-term future, and I don't think we can really rely on that financial forecasting in that way. So I'll just pick out one or two of the figures here for you. So we've been looking at the kind of capital construction cost. Of course, there's no capital construction cost if we do nothing. And if we wanted to go currently with current indices, with a little bit of optimism bias built in by the QSs, so, you know, caveated figures, probably excluding all the volatility in the market at the moment as well, we're looking at about 1.45 million to bring that project to fully certified retrofit. So that's about £3,800 per metre squared, which is around about the new school building metric that SFT have set, depending on scale of school, of course, currently. And a couple of the other figures there, I mean, with that, we're getting a 90% reduction in emissions, and we're getting a, you know, almost 80% reduction, 88% reduction in the energy demand. So we're really driving down consumption. which, again, it's all a matter of priority, isn't it? Is capital cost a priority? Is actually achieving the targets that we've all signed up to a priority, and how they all sit together? So this is what we started to try and do as part of this study. And part of the swaying of convincing people that, you can't just swap heat pumps in and continue as business as usual. If we took this school and we looked at swapping heat pumps in, the output from heat pump technology and distribution, as has been evident in other presentations today, is that we are looking at a lower surface temperature distribution, and we would need roughly 3 times the amount of heat emitters. Bearing in mind retrofit, it's not easy to retrofit underfloor heating. It's great in a new build, but we'd be retrofitting potentially with large oversized radiators. That in this school, we'd go from 19 radiators to 77, just to deal with the existing energy demand. So this is what this graph is trying to show, that we'd actually be able to put in smaller, more efficient systems, less heat emitters, because more space for teaching and learning. Okay, ventilation might get slightly more complex. As we get more airtight, we need to introduce more mechanical ventilation. But that is also complying with BB 101, getting to really, enhanced levels of indoor air quality, rather than just relying on natural ventilation on its own, which can be hard to control. You can't keep ventilation at a steady rate with just opening and closing windows and relying on wind pressure. We need to be a bit more tectonic than that. But I think the really impactful part of this graph is that, we go from 19 to 77 radiators, and if we went to full Passivhaus levels of retrofit, we'd be back down to about 11 or 12 radiators. And again, in practical terms, in capital terms, in labour terms, in installation terms, all those figures are really, really significant. And as Peter's been saying, if we need to kind of get on this and hurry up and do it yesterday, we need to not be worrying about trying to fit 77 heat emitters into one building. I talked about the heritage aspect, and we're doing this, it's actually on site at the moment, the Cambridge Institute of Sustainability Leadership. It's one of the buildings exhibited at some part of COP this week, and I'm embarrassed that I can't remember where it is, but it's one of the biggest Enerfit retrofit projects in the UK at the moment, of a non-domestic scale. And this is applying some of the learning we've done from that project in relation to how we could approach different energy measures for, a conservation window in the Scottish context. So obviously, on the left is do nothing. We could improve the fabric a little bit with a little bit of internal insulation and maybe bring in a double glazed low E window in on the inside, therefore not affecting the externals. We could try and do a mock-up, create a double or triple glazed sash window, which again, the embodied carbon, cost and time and weight of that would be probably bordering on the ridiculous. Or we get really brave and we say, right, improve daylight factor, improve thermal performance, slightly more internal insulation, and maybe a new triple glazed window. And, HES, we've been consulting with them about this, Historic Environment Scotland. The conservation planners in Cambridge really supported this on our other project. And it's really about, we can talk about the heritage characteristics of buildings and how, we might want to change some of them. But when we're in a climate emergency, what's really right to change or not change? What's the new vernacular? What is driving the functionality of our buildings for the next 100 years as well as the last 100? So I'm not suggesting that we get rid of all the sash windows all over Edinburgh and Glasgow. I think I'd be probably put in prison for that. But I think we do need to think about the meaningfulness around how we approach retrofit in a climate emergency and how pragmatic we need to be for the next 100 years. And similarly, the deep dive assessment really provided valuable insight into maybe how we could treat hard-to-reach areas. So, there was a little bit of opening up work as well, and we can see that there was a huge infiltration and cold bridging issue in various parts of this buildings that just can be simply treated and carefully treated to resolve with relatively, little hassle and interference internally. So just come to closer to the end. So we provide, a huge amount of technical information. A lot of these solutions and resolutions at policy level need technical backup, need that technical level of input, not just by us, by lots of different people. But how can you help a multi-headed client, a government, a committee, councillors, how can you help them make decisions? So what are we trying to define as the decision-making here? And of course, we know it's a climate emergency, but we know that's an emotional subject, and we know that there's other criteria that fit into that and can be enhanced by that approach as well. And some of them are listed there. So, the heritage impact, the capital costs and operation costs, the operational carbon, the embodied carbon, the whole life carbon, health and well-being, post-viral, COVID world, that's suddenly become really, really significant. So indoor air quality, we're all aware of it. Some of us have gone out and bought CO2 monitors for our own offices or our own spaces. And how do we quantify or actually visualize outcomes for those issues so that councils and governments and people and landowners and social landlords can make decisions on these things? Well, we tried ourselves. So we said, okay, well, if we give ourselves certain weightings that we can work to, in a do-nothing scenario, well, capital cost is clearly the most important thing because we haven't spent any money on the building apart from the ongoing maintenance of it. When we get to option 3A, 3B, the kind of middle-of-the-road options, as we call them, we suddenly start maybe caring a bit more about operational energy and what that cost might look like over the next 30 years to our estate. And when we get to, an 88% reduction in energy demand, we suddenly start getting other benefits when we follow a kind of valid methodology like Passivhaus or Retrofit around really good indoor air quality, so health and well-being, the human factor comes into those spaces. Suddenly embodied carbon or operational carbon becomes much more important than capital cost. I mean, capital cost doesn't go away. So I would say on the right-hand graph, we've probably undervalued capital costs a little bit there because we're so passionate about trying to do the right thing. But of course, a client, capital cost is really important, so it's always going to rank in there. But it can really affect the outcome of how you make these decisions. So, we've not made the decision for this council. The council need to go and make the decision themselves. But we've kind of suggested a total performance index for their decision making for 400 buildings. That each building is going to have a different outcome or solution, or there'll be a push and pull in a certain way. And if they look at that index or that criteria and then apply a weighting to each of those criterias, and you could have, so many subcategories of criterias in terms of whether it's to do with the heritage status of the building being most important, or for the 1970s school that's quite easy to retrofit, something that we'd probably usually demolish and rebuild. Maybe the reducing the carbon as much as possible in that school is the way to go. And trying to balance that then across the different intervention levels that we presented. So from the do-nothing approach to the low intervention, middle intervention, and high intervention, depending on how you want to rank those weightings, you're going to get quite different outcomes. And when you extrapolate that to a whole estate, on balance, that whole estate could create a really significant reduction if the cost investment is put in at the fabric first stage, which is addressing energy at point of use in terms of the building, rather than relying on, the wind farms being built 12-fold, as Peter's presentation suggested. We can't wait for that solution to come rescue us. We need to start looking at the fabric. So in summary, we tried to kind of visualize what were we saying. So, we obviously can't do nothing. We have significant cost to the public purse, even with option 2A or B. So even if we go for a low intervention retrofit, there's still a huge KVA and incoming electrical demand coming to those sites. So the public purse is going to have to invest in lots more heat networks. How heat networks might work in Edinburgh, in a heritage city, and how it would work before 2030 will be quite a big challenge, which again brings us back to fabric first. If we start reducing the fabric demand, we start reducing that utilities demand and reducing the dependency on the grid. And like the presentations we saw today, if we can somehow bring that demand down and look at load management and load offsetting within the grid, if the infrastructure is there in time, which it may not be again. So we are in an absolute race against time, which really only lives this with fabric. In an ideal world, every single building would be targeting the highest level of retrofit possible, but we're not in an ideal world. But that would be where, there is least impact to the public purse, but maybe a bit more disruption initially to actually get that retrofit done. And, that disruption is only a time issue for the next 2 years or 2.5 years of that disruption to kind of save that building for the next 100 years of its life being a low carbon, low impact building that's not creating, is creating 88% less emissions. So I suppose this study isn't finished. I'm not producing kind of hard conclusions here. It's almost like a toolbox talk or discussion. And there's other whole estate costs going on in the background. So like some of the figures that Peter has been presenting there, City of Edinburgh are actually looking at those live figures in real time at how much capital investment needs to go into this for the next 9 years if this was the final decision that was taken. And it may be well a blend of decisions. But just to summarise, I mean, energy consumption is a key driver, and the reduction of that consumption has to be the very first thing we look at. So just echoing Peter here already, being careful about how we apply the energy carbon boundary, so having an actual knowledge of how that exists so that we're not pretending that we're hitting a policy target, we actually are physically implementing it. Looking at that total performance index and taking it forward more, what are the critical criterion that can support trying to be a bit better in relation to the climate emergency and retrofit. And looking at the asset value of buildings in 50 years' time. So if health becomes a significant asset value, which it is already, but if it starts becoming kind of monetized, as well as looking at building passports for carbon, etc. We're suddenly into a different range of looking at investment options and funding of proposals to make this stuff actually happen if we could actually forward project. But our financial forecasting is so pessimistic, we don't really see beyond kind of the end of our nose with it. So, I mean, I'd urge anyone to read Lord Stern's 2006 report on climate emergency economics, and he's just released another paper over the last few weeks, I think, as an update to that, looking at that financial forecasting and climate accounting, which is how we should be looking at buildings. And of course, we've just focused on heat pumps here. There's a raft of other materials out there in terms of storage, load management, phase change materials, but we just wanted to keep it really about fabric first and the approach that's really common out there at the moment in the market, which is the heat pump market. And of course, I haven't touched on hydrogen, and again, it depends what kind of side of the bed you get out of, but hydrogen's very much either dead in the water or still a very viable solution. And I think, we just need to wait to see how hydrogen settles over the next couple of years in terms of how genuine of an alternative it can be, but not likely for buildings, maybe in other industries. So yeah, the next steps for us really, City of Edinburgh have something like 38,000 tonnes per metre square per year of carbon on their existing educational and business estate stock to reduce to net zero by 2030 and 2035. And the reality is they're not going to be able to do it by 2030. It is 9 years away. That this is a huge undertaking to try and do this to that scale of buildings in that time. So echoing what Peter has said, 25,000 for 520 or 25 million buildings, we probably need to start urgently. And facilities like this need to be every 5 kilometres for us to be able to kind of implement that. So, what we've tried to do is set out a framework, and this technical study, because it is quite technical, is going to establish a kind of framework of acceptable targets based on past 2038 and best practice principles from elsewhere, like the Passivhaus Institute. And that kind of informed methodology then can be filtered through client documentation, procurement routes, and that there's almost a plan, a pre-retrofit plan for every single building to be done in a healthy and safe way with, that energy demand reduction at the centre of the ethos of the project being procured. Okay, thanks.
Thank you so much, Anne-Marie, and thanks for sharing that project with us, and really interesting to see the Retrofit informed plan being put into place. I would now like to welcome Matt Stevenson from Ecosystems Technologies. And Matt specialises in timber and digital innovation with a strong focus on the development of homegrown timber solutions, specifically the commercialisation of homegrown cross-laminated timber. Matt collaborates on a wide range of different projects such as Fit Home, Social Bite, Homeless Village, and more recently Retrofit Homes, the retrofit solution, in response to issues arising from the pandemic, which he's going to talk to us about this afternoon. Welcome, Matt.
Great. Thanks, Caitriona. Thanks very much. It's great to join the discussion today. I've got a clicker, haven't I? It's not going to do it by itself. I'll start perhaps by giving a bit of context to the work which we're doing, within which the Near Home project sits really comfortably. And it's about a collaboration between ourselves, Construction Scotland Innovation Centre, where we're delighted to be hosted, and Edinburgh Napier University, along with a number of other stakeholders. But what that looks like, and it's manifest in a lot of the projects which you can see on the factory floor today, we've been successful in securing Innovate UK funding, £1.4 million to create the Transforming Timber project. Within that project, we're bringing together the innovation, the research, and as ecosystems, we sit as the commercial accelerator, where we try to really propel those innovative ideas forwards and through applied innovation, really add value. This involves us moving homegrown products up the value chain. So that means delivering versions of existing products, but also innovating the development of new products. And we do that through the lens of a 5 capitals approach, where we look at a balance between physical capital, natural capital, social, human, and financial capital. And really importantly, getting a balanced approach between those. And in addition to that, we look at responding to the key drivers which we have to address as an industry, which are sustainability, culture, productivity, regulation, digitization, and skills. And through doing that, we look to create and add value, and we do that through optimizing a product family architecture which is relevant to the end application. And I can speak specifically about how that relates to the near home application here, but it's manifest in each of the projects that you can see here on the shop floor. And just quickly on this slide, that Innovate UK funding is really valuable because it allows us to really sort of accelerate through this digital thread from technical design through the digital twin of that, the component prototyping, creating a host and a series of living lab projects, again, which you can see on the shop floor, and which Near Home is a key member of. All of that allows us to create a platform for scale, for full-scale manufacture, and for follow-on products. And it's a virtuous cycle that keeps regenerating new opportunities and new ideas. So specifically about Near Home. So Near Home is a collaboration funded by the Scottish Government funding via Transport Scotland, made available to Construction Scotland Innovation Centre to bring together a really strong design team to bring this project forward. You can see all of the different collaborators on the screen here. It was tremendous to work on this project. We acted as lead designer. I'm going to see if I click again. I'm trying not to be impatient, but hopefully this video will play. Should I click again? Nope. Thank you. Well, I'll keep talking whilst hopefully we get the video animation kicking in. But we were tasked through this project to create a near-to-home work solution, addressing essentially the potential for people to migrate back to commuting to work, and moreover the danger that would shift even towards commuting in cars more than using public transport. What we were asked to develop is an open source platform that could be delivered at scale, and with an initial focus on a retrofit marketplace, but with the potential of a system that could also be used for new build scenarios. And refreshingly, with a real focus on the value of adopting homegrown timber products within that. I don't know if the video is likely to work. Do you think it will, or you can always drop out and do it on another screen? I'll happily keep ad-libbing in the meantime. So what's great about what I described as the series of projects which we're delivering as the Transforming Timber project is that each project informs the next one and vice versa. So the structural solution which we adopted for the Near Home solution actually has its origins in the Synergy Home that is behind you. Within the Synergy Home, we it's a 2-story modular build, and to achieve that, to achieve the servicing within that, we wanted a spine through the middle of the building, which was clear of structural blockers. And in order to do that, we developed what we've described as a glue-laminated timber portal. So this is a new product developed in collaboration with Edinburgh Napier University and Dr. Andrew Livingston and his team there. And what that served to do was to create a hybrid between a glue-laminated and a cross-laminated timber product, such that the knuckle at the corner of, if you imagine a portal being a big rectangle, the corners need to be incredibly strong, and the bits in between, less so. So we looked to get the benefit of cross-lamination at the corners and simple glue lamination in between, which sought to optimize the use of the wood fiber that we have available. Because we want to use more wood, but to be viable, we want to use only as much wood as we need to. So that was deployed in the Synergy 2-bed demonstrator. And as we came to look at how we deliver the near-home solution, we needed a solution that could be create a box within a box, essentially, within existing buildings. So our first context for that was a vacant retail space in East Kilbride Shopping Centre. And that has an okay existing fabric, but we also wanted the context of what if we go into a historical building, what if we go into any number of range of buildings that might or might not have a good existing fabric. We want that solution to be able to be autonomous and to be able to bring all of the characteristics that we're looking at. So the glue laminated timber portal provides for that. Let's have a look. That looks promising. So I'll catch a breath whilst it plays. So you can see here the glue laminated timber portal frame, and I'll discuss in a bit more detail why it explodes and has that timber knuckle. But essentially, with infilling between these frames, we have a series of timber wall panels which are standardized, but which we can customize the internal finish to suit the project needs, to suit an aesthetic desire. And that can all be assembled and disassembled and retrospectively reconfigured. So this is us going into the space at East Kilbride Shopping Centre, imposing a grid and bringing in the structural frames. Within that, we're then populating it with the key panelised elements, but then also internal and external, internal fit out within that. Lighting was a key aspect within this initial design piece, because there's no windows within the context of that, and Seam provided fantastic lighting design. So you can see there the originating project partners and all of the project partners who delivered a fantastic piece of work. And there's a phenomenal report that came on the back of this that I'm sure we can get access to if it's useful. We don't need to play it again. Within the work that Edinburgh Napier University did and Andrew Livingston, it created a structural configurator. So that allows us to have the computational mathematics that sit behind the design process that means that we can go into any new scenario and input the key characteristics of the building of the space. And that included at this stage whether it's indoor, outdoor, what the clear span is. And we're at a point with the original design that we can achieve up to a 10-metre clear span. We then did prototyping of some of the key elements. So just to talk a little bit about the knuckle, as I'm describing it. So you can see from this we have, and you can see it over in the space over there. If I do this, then you won't be able to hear me. But if you imagine I'm holding my arms open, we've got, maybe a 1.3, 1.4 metre size element. Now, that has two benefits. One is we can get it through a doorway. The other is that from a circular approach, and again, tying in really nicely with the other project work which we're doing, it uses some of the offcuts that result from our CLT manufacture. Those offcuts result because we don't currently have use of a finger jointer which would allow us to use that waste stream directly into more of the CLT product. So by evolving a system that uses, within that one knuckle, we can use a 600 mil offcut, an 800, 900, 1200 and 1800 mil offcut. So that allows us to fully utilize the waste arising from the CLT project, which means that the two can exist harmoniously together, and it means that the whole process can be more viable. However, when we do get finger jointing line and we do move to scale manufacture of the CLT, this absolutely has the relevance and the appropriateness to continue to do manufacture in this fashion, because it allows us to transport this to site at a scale that can be manhandled and installed efficiently. You can see here some of the decorative infill panels as well, again using all homegrown timber. In this instance, Sitka spruce, but we can look at using larch Douglas fir, other species as well. And the knuckle and the column interconnect with what's akin with a sort of Japanese joint system. And what's relevant about that is the knuckle is doing all of the work. We've got from an engineering perspective, we've got a moment connection at the corner that works incredibly hard. And the point where we have a connection between that and the column and the beam doesn't have to work very hard at all. And it means we can have standardized elements that then, where we then make up the column and the beam to a suitable length for the project-specific scenario. So within that resulting system, we then can layer in all the different utilities, all the different spaces, all the different bits that would make for the appropriate office, and that's going to vary from project to project. But 360 Architecture did a fantastic job of looking at this from a placemaking perspective, from what are all the components that we may wish to be able to have available in this system going forwards. You can see this first hand over in the space behind us, and we've just got a very simple mock-up of that set up there. But what you can also see in this, and hopefully this one's going to work, is the design toolkit which we've subsequently evolved, that is an enhanced configuration tool. So what this allows for us to do is to import a floor plan from another piece of software, and to create automatically generation of a live grid, which we can then go in and adjust the grid, adjust the configuration to suit the project specifics. And what you can see is as we change things everything automatically adjusts in its configuration. We can then look at the internal sort of configuration of that space, and adjust and change. And we will have baked into this all of the space standards, all of the structural back end of things, so that as you come to a chosen solution behind that, from that predetermined palette of options, you can pretty much press go at the end of it, and your components can go directly into production. You can then change elements across across the design solution. And we've got, excitingly, we've got all the sort of metadata that sits behind that allows us to know exactly what's in the build, exactly, and that's characteristics down to the, global warming impact, the amount of carbon, the cost, the time for manufacture, service life cycle information, and so on. So do go and have a look at that further if you're interested to do so. So it's an exciting platform which we've developed as an open source platform. We want to see that rolled out at scale, and having it open source is important to do that. We would make sure that we can service that with the delivery of the componentry that would be required, but we also want that to be democratized so that individuals can do that themselves, but importantly, communities can perhaps establish the capability to do that. There's an opportunity through a system that can be replicated and a methodology that can be duplicated to create local economic benefit, to create enhanced skills, and so on. And that can be Scotland-wide, but I've been having some interesting conversations this week about how that could have a global relevance, which is exciting to consider. What we also have in the broader design toolkit is a system that has multiple applications beyond that office-based retrofit solution. We can look at deploying that as a new build system as well, which could do for offices, could do for residential. But we're having really exciting discussions at the moment about how elements of that could be incorporated into schools' retrofit solution. We've obviously got the Gen Zero new school build prototype over in the corner of the factory over there, which is a hugely exciting project to have been involved with. The potential to combine that with a retrofit solution is incredibly exciting. If we can aspire to offer and be part of creating schools for the future which have that healthy, natural, timber-based, sustainable environment within which to study. That's a really exciting aspiration. But in doing so, that we can combat the climate emergency and have build fabric solutions which are carbon positive rather than carbon negative. That's exciting. So we're working in collaboration, starting to work in collaboration with Hampshire County Council around the Scholar Schools Retrofit project, where they've got 400 buildings alone within Hampshire that need to be retrofitted. So you can imagine the scale of impact that a solution like that could start to have. And similarly, we can achieve a 10-meter span with the setup that you can see over there, but we're evolving an 18-meter clear spanning structure, which we already know we can achieve 18-meter clear span, so we could produce sustainable small business units, for example. But we also are confident that we can get that span up to maybe 24 meter clear span. So yeah, we're excited by the applications of that. And just to circle back to how that all now relates to the wider transforming timber piece, this all becomes part of that expansive process of expanding the commercialization and use of biogenic products. We can strengthen the impacts. That allows us an environment in which we can continue to incubate, accelerate, and drive more innovation and R&D forwards, and it's a platform for more collaboration. So if there's anyone who wants to collaborate on the back of this, do give me a shout afterwards, and I'd be delighted to speak more. Thank you.
Brilliant. Thank you so much, Matt.